Hey class, Mrs. Scott here, and this is section 1C of your notes. So today we will be talking about evaluating an expression using substitution. So here it says, in math, we evaluate an expression by completing the mathematical operations until that expression is fully simplified. We can also evaluate an expression with variables if we know a value for each variable. That's what we're doing today. This case, we call it substitution. Substitution is just a really fancy way of saying plugging in. So we are going to plug in values for variables and evaluate. Substitution you're going to use all through your math career. You're going to use it when you're checking solutions, when you solve equations. You're going to use it in calculus when you do things like something called U substitution. Substitution is an important concept that's just going to keep coming back up. And like I said, it's really nice to be able to check your answers in math. You'll always know if you get the right answer by simply plugging in and checking your work. Okay, so let's go ahead and start. This gives me that x is 8. So I'm going to highlight that. I always like to use colors, you guys know. X is 8, y is -2, and z is 12. Then it says, knowing that information, let's evaluate these expressions. So all I'm going to do, you guys, is anytime I see an x, I'm going to replace it with an 8 because we know that the value of x is 8. Anytime I see a y, I'm going to replace it with a -2. And when I'm replacing with a negative, I'm going to be really careful because I'm going to use parentheses because negatives, you know, they throw things off sometimes. And then finally, z is going to be replaced with a 12. All right, so I'm just using colors to kind of show you where things are going to be plugged in. And now I'm just going to plug and chug, as we say in math. So we're going to take a 6. Instead of an x, I'm going to plug in 8. Okay, minus 5 times -2. Oops. All right, and then we're going to just go ahead and now we're just going to do the math. You can use your calculator, you could do it in your head, however you want. Okay, so 6 times 8 is going to give me 48. Now be careful here. This is where I said negatives can throw things off. -5 times -2, negative times negative actually turns to a positive. All right, so we end up with 48 plus 10, which is 58. And there's my final answer. So I'm going to do the rest of this pretty quickly, but that is the gist of what we're doing here with substitution. Okay, I'm not going to color code every single one. I just wanted you to really see on that first one. So we got -3, z is 12. So -3 times 12 plus -2. Again, I like to use parentheses around the negatives especially. And now let's evaluate. -3 times 12 gives me -36. Plus -2, I can use my calculator for that, or I can do it in my head. It's -38. Final answer. Moving on, we got 7x. Okay, well, x is 8. Plus, now with these letters all right next to each other, it's going to imply multiplication. So I'm going to take the 2 that was there, multiply it by y, which is -2, and multiply that by z, which is 12. Okay, 7 times 8 is 56. Okay, now for here I can use my calculator or I can do this in my head. 2 times -2 is -4 times 12 is -48. So 56 plus -48 is 8. And that's the final answer. Last one, x plus y plus z. Okay, x is 8, y is -2, and z is 12. 8 and -2 is 6, plus 12 is 18. Final answer. So that's it, guys. That's plugging in. And that's the main type of substitution. There's two other kind of examples that I have here. So we're going to quickly go through those and we'll call it a day. We got example 2. If x equals 5, what is y? Okay, so I know that x is 5. I'm just trying to figure out what y is. So plug in. 3 times 5 is 15. So y is 15. So these are actually equations that they're giving us. Equations have an equal sign. And if I know one of the values in the equation, then I can solve for the other variable. So the reason I'm doing this one is it's just kind of a precursor to solving equations. So if x is 5, what's y? 5 plus 6 is 11. Okay, y equals, plug in 5 for x, because x is still 5 here for all these problems. 5 squared is 25, plus 2 is 27, so y is 27. Beautiful. And last one. There's more than one way I can do this one. I could distribute that -5 to start, or I can just plug it in. Plug in 5 right away. I always think that's easier. Order of operations tells me I got to do my parentheses first. So I get -5 times 11, which is -55. So y equals -55. And that is the final answer. Last type of problem is going to involve something called a table of values. A table of values is a table with input and output values. I like to think of it as repeated substitution. Okay. Uh-oh, my iPad hasn't been backed up in 2 weeks. Table with input and output values. Better back it up. Okay, what are input values? The input values are always my x values, and the output values are the y values. And the reason why the x's are inputs is because they give me all these x values. I'm going to put those x values into the equation, and it's going to spit out an answer, which is going to be my y value. Hence, input, the x goes in, output, the y comes out. That's the deal. And again, I think of it as repeated substitution. So I'm just going to keep plugging into this one equation. So this is going to be 3 times -2 and then plus 2. Okay, 3 times -2 is -6, plus 2 is -4. So I'm doing a lot of this in my head, or I'm using a calculator. And I'm just going to keep doing this. 3 times -1 plus 2. So that's -3 plus 2 is -1. So I'm just plugging all of these x values into this equation every time. Same equation. That's why I think of it as repeated substitution. 3 times 0 is 0. 0 plus 2 is 2. 3 times 1 is 3, plus 2 is 5. Last but not least, 3 times 2 is 6, plus 2 is 8. And there it is. So I used substitution to find all my output values of this table of values. And then the same thing goes with the next one. Let's use a different color. I'm going to plug in to this equation, y equals 1/2 x plus 2. So I'm going to plug in. Now, sometimes, we see a fraction, looks a little freaky. I just think when I'm multiplying 1/2 times any number, I think what's half of that number? So what's half of -4? -2. -2 plus 2 is 0. What's half of -2? That's -1. -1 plus 2 is 1. Half of 0 is 0 plus 2 is 2. Half of 2 is 1. 1 plus 2 is 3. And half of 4 is 2. Plus 2 is 4. Awesome. So that's it, guys. That is the whole lesson. So just to recap, we started by having examples where they give me values for several variables and I just plug and chug into the expressions that they give me. The second type of example was they gave me an x value. I had to plug that x value in and find the y value. And the last type of example is this table of values where we're just going to repeatedly plug in the x values into the same given equation to find all of the corresponding y values. These practice problems are going to be done in class. So that's it for today. Well done. Until next time.